Hi everyone, we are team number 10, London Aquatic Centre. This week, we'll continue to present the overall construction of our building. Beginning with reviewing last presentation, we will talk about cowl zip system they used and drop ceiling and material, and we're gonna tell you why they used this material in terms of our building system by further research. Last week, we studied about facilities such as ventilation, heating, and water system. First, London Aquatic Centre employs a variety of ventilation techniques, including both natural and mechanical methods. They try to make the air move in a certain way. Air is supplied to the major event spaces using oversized ducts below the pool deck, providing the freshest air at the level of highest activity. To achieve heating and cooling, the water heats up the air at the base of the curtain wall, which then rises until it reaches the top of the water, where it then begins to cool and descend softly back into the interior. This continued movement of the air also helps to solve an even greater problem than comfort, that is condensation. Let's talk about the roof panel. You can see the wide smooth roof from the top. The roof of the center is made of aluminum sheet. How can a metal sheet smoothly cover a white roof with such a dramatic form? The answer is in the cowl zip cladding system. This system is a flexible, water-resistant, easy to install, and lightweight construction system, which can be used to large building surfaces without difficulties. It has several key advantages that the Aquatic Center chose this system. First, it is specialized for individual design for variation in unusual building shapes. The London Aquatic Centre is an unusual shaped building. Its roof shaped like a wave sweep from up to ground, right to left. With highly flexible aluminum sheets, they can cover any curve or wave-shaped roof. To make the fluidity concept of the roof to the real world, cowl zip system was suitable for the center. Second, it offers exceptionally durability. If you use steel sheets on roof, it is more cost-effective and provides the optimum in loading and spanning capability. However, cowl zip system used aluminum, which provides exceptional durability in buildings in humid conditions, such as swimming pool or wet industrial plants. Also, the aluminum sheet overlaps each sheet beside it. A shield at the joint of sheets prevents water seeping through and into the roof structure. So, the center chose the cowl zip that has durability in water from inside to outside. Lastly, it shortened the construction time, as the center has a serious deadline called Olympics. Their construction time should be scheduled effectively. If they made the roof in normal ways, they had to make the whole roof components fabricated and bring them into the site. These whole steps cost time, and if the prefabricated components was not fit, it would delay the time more. However, the cowl zip system offers on-site production. The components don't have to be prefabricated and transported. Instead, they could just supply the right sheet when they are needed. So overall advantages make the center choose the cowl zip system for their roof. Now, let's talk about the drop ceiling. Drop ceiling is a secondary ceiling, hung below the main ceiling. It may also be referred to as a drop ceiling, T-bar ceiling, and false ceiling, drop-in ceiling, and drop-out ceiling, or ceiling ties, and is a staple of modern construction and architecture in both residential and commercial application. The hanging ceiling in the aquatic center is a carefully planned and orchestrated element. It consists of 37,000 pieces of precision-cut Brazilian lumber. Each element of the ceiling is made specifically for the spot it is placed, including metal brackets. Then, let's talk about how to make drop ceiling. First, with the materials prepared, hang up the main rubbers by the wires. Next, install a secondary rubbers perpendicular to the mains by clipping them in place. Finally, lift the ties through the grid and set them on top of the grid. Finally, let's talk about advantages of drop ceiling. First is ease of modification. Another advantage of drop ceiling is that the easily removed ceiling panels offer instant access to the planium, which is greatly simplifies repairs or alteration. Wiring and piping installed behind traditional plaster or wallboard ceilings are extremely difficult to modify once the finished ceiling is in place. Wires must be finished through hollow spaces in the walls behind the finishing ceiling, or the ceiling must be demolished for the changes to wiring or piping to be made. In contrast, the ties and other parts of a dropped or stretched ceiling can be easily removed to allow access to the area above the grid to do any necessary wiring or plumbing modification. In remodeling, thereby all components of the grid can be dismantled and reassembled elsewhere. To address fire safety, ceiling ties made from mineral fibers, plastics, thin composite or fire-rated wood panels can be used within the construction to meet accessible standard ratings. Drop-out ceilings have a further advantage since they can be mounted underneath fire sprinklers, thus hiding the sprinklers for a more attractive appearance. And we will talk about how they use the two main materials to resolve problems when construction period at the London Aquatic Centre. One is GGBS concrete. The London Aquatic Centre doesn't seem to have much concrete use in appearance, but the London Aquatic Centre ground structure is massive concrete structure. The massive concrete structure have some problems. It could occur the thermal cracking and need good workability of concrete because its amount. And humidity arise from the pool can affect the durability of massive concrete. First of all, let's talk about the thermal cracking. If the massive concrete structure, then there can be a large temperature gap between the center and outside during curing. In other words, because a lot of concrete at the center makes much hydration heat, the center is red color and the outside is blue color, became temperature difference. The center part, which has high heat expand, on the other hand, the relative cold outside part gets shrinkage. This difference caused the thermal crack. To prevent the thermal crack, the London Aquatic Centre used the ground granulated blast slag. The DGBF is concrete admixtures obtained from the blast furnace and can replace the Portland cement about to 40 to 50%. The GGBS reduces the hydration heat of concrete so that the massive concrete structure can maintain even temperature state. So, when they use GGBS concrete, the temperature gap between the center and the outside part gets smaller. The thermal crack can be prevented. And the GGBS particles have a very glassy texture that makes them increase the workability. This can help the reduction of water to get adequate workability in common situations. In other words, good workability can reduce construction risk so that can ensure the scheduled construction period. Another material is Brazil hardwood. As mentioned, the Brazil hardwood is same to Brazilian rubber. It uses on the sailing due to its humid climate. At normal, the hardwood lasts for several decades and can resist the humidity. And the Brazil hardwood can make the roof's curvature shape by cutting 37,000 Brazilian wood ribs individually. The 37,000 ribs have their position, so each rib should be installed the right place. The installation proceeds as follows. The light weight of wood ribs relative to steel or concrete can make the workers to directly install the ribs on a lift and put it its own place. This is our end of presentation, and next week we'll sort out the important information and do the final presentation. These are the members of our team. Lee Jun-soo, Im Hyung-gyu, and Yang Jae-young did research about the call-zip system and drop selling and material. And Ko Jae-sung, Shin Sun-woong did PPT and the narration. Thank you for listening our presentation.